So I'm going to talk about monitoring with Prometheus, how we do it at my current company. So this is like obligatory self-promo slide. So I do deal with infrastructure at a small Polish startup called DevSkiller. I'm a great fan of free and open source software and open hardware. I started to automate stuff some time ago, and this love for automation is still there. So like I do like automation. And I'm also a co-organizer of the Warsaw Linux user group. And we are looking for speakers and for venue and for everything. So if you would like to join Warsaw Linux user group, let me know after the presentation. Okay, so what is Prometheus? So Piotrek asked you like how many of you uses Prometheus. So there was like quite a lot of people using Prometheus in this room. So it's an open source monitoring and alerting toolkit, which is written in Golang. It was inspired by Google software called Borgmon, I believe. It was started in SoundCloud in 2012 and then joined Cloud Native Computing Foundation in 2016. As I told you, it's like the go-to monitoring system when we are thinking about cloud native stuff, Kubernetes. I have issues with spelling the name, or like microservices, right? And it's very, yeah, it's suitable for that. And like it has everything included, what is required for your monitoring system, including alerting, some kind of graphing stuff, and dashboards as well. So when we know what is Prometheus, like when you should use Prometheus. So it's basically it works the best. It's the best at recording any numeric time series, so it was designed for it. It was designed for reliability. So basically, if you need a reliable system for monitoring, the Prometheus would be worth considering in your project. So it's like there are no external dependencies. You don't need, I don't know, distributed storage like Ceph or whatever. You don't need any databases and stuff like that. Just a single statically linked binary written in Golang. You can run it on your server, even in screen or whatever. Just don't do it. But if you do some testing, you can do it. And it's very well suited for monitoring infrastructure and distributed systems, basically. But there's like a lot of solutions. There are like Nagios, Sensu, Graphite, Zabbix, you name it. I used a few of them. In my previous company, I used Zabbix, and then I switched to our own in-house solution called M3DB at Uber. And Prometheus is like, to be honest, it's like one of the best tools I've been using so far. It's it has a super nice language, and all the batteries are included. So it's so sweet, but when you should not use Prometheus, like when you need like 100% accuracy. Imagine the situation when you have a service and you are, for example, billing your clients for every request they make to your API or whatever. So you shouldn't use Prometheus for that. It wasn't designed to be the system for that. Also, when you need to store your metrics for a long term, for example, you are collecting some metrics from application, and you can do what, I don't know, like some kind of prognosis based on those metrics. Prometheus is not the system you would like to use. And when you need downsampling, for example, you would like to store some metrics with resolution of 5 minutes for a week, different resolution for a month, and different resolution for a year, like you used to do it in Graphite or in FluxDB. It's not possible in Prometheus, like in Prometheus. Okay, so I've been using Prometheus for more over the year right now at my current company, DevSkiller, and we use it for a lot of things. Like basically, I started to use Prometheus at DevSkiller for monitoring infrastructure. When I joined the company, we were using New Relic servers, which was it was abandoned by New Relic, and they switched to another product, so we need some other solution, and we decided on Prometheus. We also monitor our application with, we send our, like, you can call it business metrics to Prometheus. And all the stuff, like we are JVM shop, so we basically monitor all the JVMs using Prometheus. And we also monitor different stuff, like all the cron jobs are monitored with Prometheus. They are not, maybe we are not alerting on those metrics, but we are monitoring those cron jobs. Okay, so like most of you are familiar with Prometheus, but let's let's describe sorry, few key concepts of Prometheus. So basically, it has multi-dimensional data model. A time series data, when you have in Prometheus, is identified by a metric name, which I show later, and unordered set of labels, which are basically key value pairs. It has a very, very powerful and flexible query language called PromQL, and it's like the biggest difference between Prometheus and, for example, Graphite, because like every time I talk with some developers, they used Graphite at some point of time, kinda, most of them, few of them, I don't know, and like they used to send metrics to somewhere, right? And then the system would receive metrics from their application, just send metrics and forget. So with Prometheus, it's like the model of getting the metrics into Prometheus is a bit different. And Prometheus is pulling metrics to its own database. But of course, sometimes we need to push metrics, for example, when we have some batch jobs or like which are short-lived or something like that. We don't want to start a HTTP server just to expose metrics from a cron job, right? So we can use the exporter called push gateway to push those metrics to Prometheus. OK, so here is the picture from the Prometheus website, and it shows the architecture of Prometheus. So we have Prometheus server, which is like the single binary I told you about. And what it does, it just pulls metrics from all the jobs it has configured. And the job is basically some kind of entity which has an endpoint where you can get the metrics via HTTP. So it's not important at this moment what was that. And it pulls the metrics. It retrieves those metrics, it stores these metrics, and it can record additional metrics based on those metrics it scrapes. And based on those metrics, we can create alerts. So basically, Prometheus creates alerts as well based on those metrics. You can use the same PromQL you use for your dashboards, Grafana dashboards, and so on to create alerts. So the alerts will be sent to Alert Manager, which is like another part of Prometheus ecosystem. And of course, we have some UI graphing stuff for creating dashboards. OK, so here we have those jobs and those metrics. And somehow we need to expose those metrics, right? For example, in Nagios or Zabbix, we were installing some kind of agent or Nagios checks to get those metrics. And now we need also some kind of binary which would expose those metrics to Prometheus. So Prometheus could ingest those metrics. So they are called exporters, basically. So they're exposing, if you cannot instrument the application, that it will expose the metric by itself, you can use those so-called exporters. For example, on Linux machine, you can use Node exporter to export all the Linux-related or Unix-related metrics. So basically, memory usage, I don't know, the number of open files, the file descriptors, and so on and so forth. If you use old Glassfish server and you have to instrument it and you don't want to touch this code which was written 20 years ago and it will explode, you can basically use JMX exporter to get a look into those beans and extract some data. There are like many exporters, like Blackbox exporter is, you can do, for example, HTTP requests for your services and export metrics based on those requests. If you have some database and you would like also to monitor it with Prometheus, you can use MySQL exporter. There are exporters for Oracle, MS SQL, and so on and so forth. At their website, I think there's like around 100 third-party exporters listed. Those are only official exporters. And from like also like this one is a really nice exporter called mtail. It's developed by Google, and what it does, it ingests a logs file. And based on this log file, you write some kind of rules in the DSL in this program. And it will parse the log file and expose metrics based on this log file. So if you have some old application like which logs something and you would like to get some metrics out from these logs, you can use mtail for doing that. OK, so as I on this picture, we have to pull those metrics. So those targets will like target is an endpoint basically which exposes the metrics to Prometheus, and then we scrape this metrics on Prometheus. So Prometheus has to know what to scrape. So basically, in the config file, in Prometheus config file, we define something called scrape configs, and so those are the targets which Prometheus will ask for metrics. So those scrape metric configs has a job name. For example, we have here Prometheus, and the target where it should connect to scrape the metrics over HTTP to pull the metrics from the service. And when you have this configuration and you go to Prometheus UI, you will see the list of targets like this one on the right. And here we have this the scrape configs and this targets here. And target is basically an instance. So for example, if you have a job Prometheus or a node here, and you can have like 100 of nodes, so you would like to distinguish between those nodes, right? They will have all the job name node, but they will have also a label called instance, and you can filter by this label and so on and so forth. So instance is the target, like actual target you will gonna pull metrics from, and the job is like collection of those instances. And of course, you can use service discovery for getting the list of your targets, and it supports Kubernetes, and it plays well with Kubernetes and all the cloud solutions as well. So yeah, as I told, service discovery will automatically retrieve scrape targets for you. So basically, if you have a really dynamic environment like cloud environment or using Kubernetes or whatever, is a way to go, really. But if you like, for example, I have an issue, for example, we use for service discovery in our application with Eureka, and Eureka is not officially supported service discovery for Prometheus, so we had to write a cron job which will basically every 5 minutes pull the data out of Eureka and create a JSON file inside Prometheus configuration directory. And Prometheus will read the definition of this file discovery file SD file, whatever, and it will add those targets to its configuration. Okay, so basically, like, so we have this exporters, third-party exporters, but the real power when we want to monitor something is like instrumenting our applications and doing white box monitoring. So there are official libraries provided by Prometheus team for Go, for Java, for Python and Ruby, but there's like multiple third-party libraries you can even find one for PHP, for Haskell, for Occam, like I guess for every language which is there, you can find an exporter. And as I told you, like getting those metrics is one thing, and we would like to do something with those metrics. And Prometheus has a okay. Sorry, I wasn't sure if it's like to me or no. So we would like to first grab those metrics, like to show them to some engineers, like or our business people. So Prometheus has a built-in expression browser where you can create ad hoc queries in it and do some graphs. And you can also create some consoles in Prometheus using Golang templating language, and you can show the graphs there. But if you want to do something more nicer, just use Grafana. And Grafana, I think, is a recommended way to do graphs with Prometheus. They have great support for Prometheus, especially starting from version 5. Their editor is excellent. So this is the screenshots from Prometheus. As you can see, it's not really nice. It's like, this is the expression browser, and this is a simple dashboard for console for Node exporter. So it's not so nice. You cannot zoom stuff, and use Grafana for that. Okay, so every monitoring, when we talk about metrics, I would like to define the data model Prometheus uses. So basically, we have 4 types of metrics in Prometheus. This is really easy. We have counter. So basically, counter is a metric type which can only goes up. Gauge can arbitrarily go up or down. It doesn't matter. Histogram, so it's like samples observations over time and counting them. and a summary. It's very similar to histogram, but it's implemented a bit differently in here. So yeah, those are the 4 types of metrics which are used in Prometheus. But what I would like to say here is like those types are not strict in the means that basically you can have a counter, like for example, and it can go up and down or whatever, and it's up to application or the author of the instrumentation library to make it work. Basically, when we have a histogram, the author of the application who is exposing the metrics to Prometheus has to make sure that the metrics names has special suffixes and so on and so forth. And Prometheus itself, when you use functions, for example, for calculating percentiles, it expects some kind of metrics names which should be provided by application. But it doesn't like do strict type checking on those metrics. I hope I made it clear. So as I told, the metrics in Prometheus are identified by a metric name and a set of the key value pairs, label name and label value. It's unordered set, so like the order here doesn't make any difference. So as I said, metric name and those labels. So for example, we have here an example metric. It's no discrete merge, so we count how many disks merge do we have on device SDA here, so SDA. So we basically identify a metric based on a metric name and the set of labels. And labels are in those parentheses. And what we call those labels are basically selectors. They select the metric. So we can have metrics no discrete merged with different label values. So based on this, we're gonna limit the metric here, the vector of metrics we're gonna get, to device SDA and instance server 01. And we have matchers here. So basically here we have that it has to equal. But if we don't want to have it equals to something, we can use different matcher, which will say it's like we want to discrete merge for device SDA, but not on instance as server 01. So it will take all the metrics with instance label set not to server 01. The same we use for a regular expression. So we can use a regular expression, so it will select all this metrics for instances which start with server dash, or it doesn't start with server dash. So yeah, this is a different thing. I will skip it. So data model, like continuing with data model, when we query Prometheus for some metrics, we can get 4 types of it can return 4 types of data to us. It can be an instant vector. So basically, instant vector is a set of time series containing a single value. So basically, you have a metric value, metric value, metric value. We have a range vector, and this was a range vector, so I didn't want to show it like now. So it's, as you can notice here, we have another set of parentheses in square brackets. We have a time. So what this time vector, range vector is, so it basically is a set of time series containing a range of data points and over a time. So basically what you get in range vector is like timestamp metric value, timestamp metric value, timestamp metric value, timestamp metric value. Another thing we can get is a scalar, so it's like a single numeric floating point value. One important thing, in Prometheus, every number is a float. There's like no integers, nothing, there's always float. And you can also get a string, which is currently unused. I've never used or seen string as in use. So what is the difference between those 2 vectors? So instant vector, we have 2 queries here. First, we will get the range vector here. So basically, it will give us a metric. For example, we have really interesting metric, the number of RAP entries on our computer. It's a very important metric. So what we get here is a metric and its values for 1 minute. So basically, if we scrape every 5 seconds, we're gonna get here 12 metrics. So it's a value at timestamp, value at timestamp, value at timestamp. And this is the instant vector, which I mentioned before. So basically, it's a single metric with a single value. Is it understandable? Okay, so no questions so far. Hold it to the end, please. Okay, so like let's continue with this data models thing. So there are a few constraints on label names and metrics names, but if you want to do it in the proper way, and like if you want your future self to thank your past self after some time of using the Prometheus and those metrics, you should get you should apply some best practices when it goes about naming metrics. So basically, they always should have a suffix describing the unit in plural forms in general. So for example, when you have node memory usage, don't just leave node memory usage. It should have bytes because it's in bytes. So basically, when you query a metric, oh, I know it's kilobytes, gigabytes, megabytes, petabytes. What is it? So basically, when you have a suffix, like we described the metric unit, it will be much easier for you to query, make graphs, and so on and so forth. And it should be always single unit. Don't mix stuff, like you don't want to have bytes and seconds in one metric, probably, as in most cases. Sometimes you need to have. And preferably use base units, so instead of nanoseconds, use just seconds. Instead of gigabytes, use bytes, and so on and so forth. And like there are also a few naming conventions. For example, when you have accumulating count, it should have like total, suffix, and so on and so forth. And labels name should be, so when you're naming the metrics, for example, have you used graphite? Like, does anyone use this graphite? Yeah, you see one person. Okay, so so my example won't make sense to you. So basically, sometimes you would be tempted to create, for example, you are monitoring some application, HTTP server, for example, and you would be tempted to create metrics names such HTTP get 200 and some endpoint, HTTP get 400, HTTP get 500, and it's not the best idea to do. It's an idea, but I would avoid that, because like you should differentiate, like for example, those status codes using labels. Then you can aggregate over those metrics, summarize, average, whatever you want to do with it. Like when you have, for example, code name, like status code in the metric name, it's almost impossible to do any aggregation in PromQL. Okay, so PromQL. So PromQL is a very powerful language. So we have few operators in PromQL. Standard arithmetic ones. We can compare metrics, and we can do binary operations on them. We can use aggregation functions in PromQL. This is very powerful, and in most of the cases, you're gonna sum something, you're gonna count something, you're gonna quantile something, and this is very important to say is like there are two keywords in PromQL: without and by. For example, because like when you would like to match two metrics, for example, you have two metrics and you would like to divide them, and to select them, they must have the exact same set of labels. So if you would like to, for example, when you have I will show the examples later, so we'll talk about it. So for example, if you have HTTP requests, and there is like one HTTP request has label instance and job, for example, and another metric HTTP request has code and status, they won't match because they don't have the same labels in a set of labels. So without and by can give you can remove the label names from your aggregations. And this is a bit harder topic in PromQL. For example, when you want to do matching in PromQL, there are 4 functions. It's ignoring, on, group left, and group right. So sometimes you need to match. You want to match 2 instant vectors whose labels do not match, so the set of labels is different, and they will help you to match them and do some operations on them. So for matching, this is the sample how Prometheus is doing matching. So we have input metrics. So don't care about those columns and stuff like that. So basically we have method code, HTTP errors rate 5 minutes for method get, put, post, and code, and we are summing it. And what we are doing here, we are ignoring code. And we are dividing method code HTTP errors rate 5 minutes for code 500 by HTTP request rate 5 minutes, but ignoring the code. So basically what we get is 24, because like we have code 500 right here, by 600, because like we are summing it up here. So we can match those metrics even if their labels do not match, because like we have label here method get and code 500, and only here we have method get. And to match those instant vectors without those functions without ignoring, we wouldn't be able to do that. The same goes about group left. Here it's a bit more complicated. By basically idea is very similar to ignoring. I will share my presentation afterwards, so you can go through the example at home and check it out. Okay, so Prometheus gives us also a lot of functions. For example, I don't know, there's like a lot of functions related to time. You can calculate logarithm, do some linear regression even, and so on and so forth. So let's go to a few samples. This is the real life, it could be a real life PromQL example. So what it does, somebody would like to guess what it does after the talk? Nope. Okay, so what it does, it selects the metric called HTTP request total based on a job label, which has to equals to API server, and a handler. So basically, when you have an HTTP application and you would like to get metrics for your handlers, this is the way to go. This is very similar. Query to the previous one. So basically, when we have a counter, like you know how counter works. So counter works as like we have a value of a counter 0, and it's going up. So our application is incrementing the counter, because counter can be only incremented. And we have an application restart. So this counter goes to 0. So it's like up, 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 0, up, 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 0, up, 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 and 0. So basically graphing it and doing whatever with this metric alone, it's like useless, basically. So what you have to do, you have to calculate a rate or something else with this counter, and rate function and like the whole family of rate function in Prometheus will handle the counter resets for you, so you don't have to care about counter resets after your application restarts or something like that. So what it does here, and it calculates a rate of HTTP requests over last 5 minutes, and the rate is like calculated per second. So it will give you for last 5 minutes the requests per second to your service. Is it clear? Okay, great. So what we have here, like it's a very similar PromQL query again. We calculate the rate, and then we sum this rate by a job. For example, when we have different jobs, we can have multiple API servers, multiple applications, and we would like to get a sum of the requests per second in our system, but grouped by the job name. So we can use this kind of query to do that. And it's like it has also a lot of functions for, like as I showed, for aggregation. So this function in particular will take 3 top instances. It will list 3 top processes, 3 top applications by CPU usage. So basically, the top K function will pick 3 top from your results, from your vector. And this is very nice query if you are running Linux and you have many Linuxes and you would like to count how many different kernel versions you have in your data center. This query will give you the count it will count all the kernel versions in your data center. So basically it will give you the vectors where there will be a kernel version and the count, kernel version and the count. The same here. It's a much complicated query. It uses group left. So what it gives you, it will give you the result would be instance name, and we will join the metric, group left the metric, with a node name info, this one metric. It's node uname info stores the information about the running kernel. Like basically when you type uname -a on your Linux PC, it will give you the same here. So this query will give you the list of instances and the version of kernel on the instance. And this is like, I have Kubernetes, I added this question. This is the query. Can somebody would like to guess what this query does? I have some stickers, fine stickers for like. Okay, so it will calculate how much memory the kube system, how much memory are the tools in the kube system namespace using. So, and we'll break it by Kubernetes pod name. It's pretty easy. Okay, so I will skip this one because like we are running out of time, I guess. And the funny, like really nice question, really nice query here. Like, how many times did you get woken up by an alert during the night that the disk is running out on the server? Anyone? So, like, Prometheus supports some simple algorithm to do linear regression. So basically, we can predict when the disk space will run out. So what this query does, it will predict linearly that what it means that if the disk usage would steadily go up on a server, and in 4 hours, it calculates what would happen in 4 hours. And if the free disk space would be less than 0 in 4 hours, it will send us an alert. Okay, so I talked about data model and metrics, and there's a different type of very neat feature of Prometheus. It's like called rules. So basically, we have two types of rules in Prometheus. One is alerting rules. I mentioned it before to create alerts. So basically, we take the PromQL query we wanted to do, put it in those rules, and Prometheus will evaluate this query every time, like all the time. And if it's true, it will send us an alert. And also, for example, when we have multiple, and different type is recording rules. For example, when we have multiple HTTP services, and you would like to get, I don't know, to calculate latency on all of them. It's like a stupid thing to do probably, but let's think about that. We need it, and you would like to, and we want to show it on a graph in Grafana. So basically, if you would like to calculate everything from scratch every time you load the dashboard, and you have like hundreds of services, it will take a lot of time. So what the recording rules does, they like pre-compute the metric you need to show, for example. And it saves, and the recording rule saves the new metric in like Prometheus database. Okay, so the rules definitions looks pretty simple. I think you all know YAML because you are on a Kubernetes meetup. So it's defined in YAML. And here we have some example rule which will record it will create a new metric called job HTTP in progress request. And this metric will be calculated by summary of this metrics by a job. And then we can create an alerting rule based on that. So if we have, for example, latency is higher than 5 seconds for 10 minutes, then send the page. Okay, so again, we have this architecture diagram. And I would like to talk about this alerting thing right now. So alert manager, how it should be set, how it works. And so basically, alert manager is a second binary from Prometheus you have to set up. It receives alerts from Prometheus, and it takes care of deduplicating, grouping, routing, and inhibiting the alerts. You can also silence the alerts in alert manager. So for example, if you do some maintenance work, you don't want your alerts to fire up. So, alert manager just takes the alerts from Prometheus. The actual alerts are created by Prometheus itself from those alerting rules. So here we have very simple alerting rule. So if we have instance down, so there's like a special matrix called up for every instance. And if it's equal 0 for 5 minutes, then we create an alert. So we apply some labels, custom labels. So for example, severity, it will page us in the night. And some annotations. So we have here summary, description, dashboard, for example, Grafana dashboard and runbook. And I would like to emphasize this, like this dashboard and runbook. For example, in our situation is very important. We have a team of 6 engineers. So when you get an alert at 2 a.m., you want clear documentation, clear runbook, what to do with stuff. We are trying to automate most of the stuff, but sometimes you have to restart the service manually sometimes. Yeah, still we do have some runbooks which has like systemctl restart a service name. But yeah, when you're creating an alert, it's also like, it's the same. Your future you will thank your past you because you added this runbook and this Grafana dashboard to your alert. So when you get the page during the night, you just click a link, go to documentation, check what's happened, fix it, and go to sleep. OK, so as I mentioned, Alert Manager is just receiving the alerts from Prometheus, and it takes care of the alerts. For example, it will route the alert to specific person. So yeah, for example, here we're gonna group the alerts by alert name, cluster, service. And for example, if you have 100 services in a cluster and they started to fail, you don't want to get like 100 alerts on your phone, because like PagerDuty will kill your phone. So what you're gonna get, you're gonna just get one alert with all the services which are down listed in the alert. So when we have this alert and we know how to group the alert, we want to send this alert to some team, some person, whatever. And right here we have some simple definition of a receiver. We have 10x mails, so basically we're gonna send an email to team X. And based on a service name, for example, we have service label on our alert. And if the service is foo1, foo2, or bus, the team X will receive an email. But if the severity label is set to critical, they're gonna get a page during the night. Yeah, so this is when we have this definition here about routing, we have to define the receivers. So we have to define the team X email. So this is an email, and we can have PagerDuty configs for pager. And as far as I know, Alert Manager support multiple services to do pages. For example, OpsGenie, VictorOps, PagerDuty, whatever you want. And the best, from my perspective, very interesting feature is inhibits alert inhibition in Alert Manager. So imagine the situation: your whole data center is going down, and like getting alerts from all the instances that are down, it's like kind of crazy. So when, for example, your whole data center is going down, you would like to get an alert that data center is down, not like all the services in the data center, right? So this inhibiting rules can do it for you. So in here, this example, if severity is critical, we are matching those all alerts with severity critical. And the target alert, which is like Prometheus is evaluating, has a severity warning, it will be inhibited. So basically, we can have alert, for example, with severity warning that disk is running out of space in 5 hours. And we have critical severity, disk is running out of space. Now it has 0% left. So basically, when you have a critical alert, we won't fire up the warning alert anymore, here in this example. OK, so a few words about operating Prometheus. So basically, what you need from your monitoring system, it has to be highly available. And the HA in Prometheus is really simple. You just set up another instance of Prometheus. So you will have 2 Prometheuses. It's a funny word when it's plural. You have 2 Prometheuses scraping the metrics from all your targets, and they can monitor each other. Of course, when you have like bigger deployment of Prometheus, you can set up Prometheus per cluster, per data center, per region in AWS or whatever. It's up to you. And when it goes about Alert Manager, it has to communicate. Like Alert Managers they have to communicate it to each other, because they keep some state, like which alert will fire it, or what alerts are silenced, and so on and so forth. So right now, they use some mesh configuration for like keeping the state. They are changing the protocol right now, but they are working on it. And like as I said, scalability. You can divide the workload. Like for example, if your Prometheus is running out of steam and you have like thousands of metrics, you can probably split the Prometheus, like have one Prometheus only for Linux metrics, one Prometheus for Windows Server, one Prometheus for application servers, and so on and so forth. And what Prometheus does, it supports federation. So basically, when you have multiple Prometheuses in your data center, for example, per cluster, you can have one Prometheus which will read the metrics from all those Prometheuses and display it on your one dashboard. And yeah, I also put here capacity planning. So basically, one metric takes about, like the rough estimate is 2 bytes. So we would have to calculate how many storage you need, because like storage is pretty critical for Prometheus. And remember, like Prometheus expects you to run it on some kind of POSIX-C file system, so don't try to use NFS or something like that with Prometheus, because you're going to have a bad time. OK, so when we have this monitoring setup and stuff is like running and we are monitoring our data center or what our infrastructure, we would like to know when the monitoring is not working, right? So we have to monitor our monitoring. So a pretty easy way, I don't know, I found it somewhere on the internet. I was watching some presentation or something. So what I do in our deployment of Prometheus, I'm firing an alert always in Prometheus, which always is getting to alert manager, and my alert manager will create an alert in PagerDuty. Then in PagerDuty, we're gonna have a webhook which will trigger a check on some kind of free or paid cron monitoring service, because it's great. Like if you've never used this cron monitoring stuff, basically there are plenty of services which gives you an URL, and you just shot to this URL, and if you are not like, if you didn't ping the URL for this service like for some time, like for example 15 minutes, it will alert you. So what we do, it's like you can have a rule in PagerDuty when it's received an alert, it will execute a webhook to this cron monitoring service and automatically close the alert. So basically you have monitoring for your monitoring, like from the start, so firing an alert on Prometheus till the end, so sending an alert from PagerDuty. And that's all. It sounds pretty easy. But you can do also some more complicated stuff. You can, for example, if you need, you can calculate latency between creating an alert and sending a notification from PagerDuty or OpsGenie or whatever. OK, any questions? No questions? Great. Yeah?
If you want to add a plugin that exports an alert to, can you easily actually like ping a URL from an alert, or do you need
from alert manager?
Yeah.
The question was if you can do a request to an URL from alert manager. Yes, you can. So for example, when you have an alert about running out of the disk space on one server, you can create a Jira ticket. You don't have to page somebody or send an email, right? Just create a Jira ticket or whatever, and you can use webhooks for that. You can use, there is also a Jira integration available for Prometheus, for alert manager, sorry. Yeah, so let's wrap up. Yeah, cool. If you want to drop me an email or like find me on Freenode, like feel free to contact me. Thank you.